The GSD8 Digital Potentiometer turns your existing loosely controlled analog system into a precisely controlled digital system because it replaces the analog pot with a digital display that can show engineering units, and it provides a feedback path that it can use to tightly control your motor's speed. And you can use it with any controller that uses a voltage reference. It doesn't have to be a DC motor controller. Let's do an example. I have a GSD8 analog drive that normally takes a potentiometer input. I replace that analog pot with the GSD8 digital pot. I have the drive connected to a 3/4 horsepower DC motor, attached a GSD8 20 PPR encoder to the back of the motor, and wired that back to the GSD8 digital pot. I also wired a switch to the S2 terminal, which I can use for inhibit, jog, or e-stop. We'll use it for inhibit. Now this should look real familiar if you watched any of the previous videos. It's almost exactly the same as wiring one of the GSD8 digital DC drives. The only difference is we're using the analog drive as a high current output stage of what is now our digital DC drive system. Everything else is identical to the previous videos, with one exception. While the GSD8 drives are all closed loop operation only, this digital potentiometer builds a DC drive that can be run closed loop or open loop. Let's do a factory reset to get the drive to a known state. Parameter 95, enter 5, up arrow to confirm. We wired the inhibit switch to S2, so let's go to parameter 35 and change S2 from a jog function to an inhibit function. We need to make sure this digital potentiometer is running in closed loop mode. That's parameter 22, and we just need to make sure it's not a 32, which is the open loop operation. It isn't, so we're good to go. Let's double check that the pulse rate the drive is expecting is 20 because I'm using a 20 PPR encoder. It is. Let's go to parameter 12 and change the display from target speed to actual speed. That's just because I prefer to see the actual speed. And let's scroll to parameter 0 and press enter to exit the parameter mode. Now the display says we're inhibited, so I'll release that, and we see we're currently at 0 RPM and the motor's not turning. Now before we ramp this up to some speed, we need to set up these configuration potentiometers on the analog drive to be compatible with the new digital potentiometer. First, we need to make sure we lower the max speed setting to roughly 2/3 of full scale. If it's set too high, the digital potentiometer may not be able to get a stable result. If it's set too low, then it may never get the motor up to speed. And 2/3 is a good starting point. I'll also turn the min speed all the way down so it doesn't limit us on the low end. The digital potentiometer can do that for us. Next, if the drive has current limiting, which this one does, make sure it's set high enough that it doesn't prevent or limit the digital potentiometer from doing its PID tuning. My motor isn't connected to anything, so there's no concern here, so I'll raise the current limiting all the way up just to get it out of the way. IR comp handles speed regulation on the analog drive. It basically increases the motor armature voltage to compensate for heavy loads. But since our closed loop process will automatically compensate for load variations, we want to turn that all the way down to get it out of the way. The digital potentiometer will also be controlling acceleration and deceleration very accurately, so we'll get these guys out of the way too. Of course, don't forget to set the power jumper on the analog drive to match your power input and the motor voltage jumper to match your motor's voltage. Great! We set up the digital potentiometer and the analog drive. Let's try it. I'll crank up the speed, and sure enough, the motor starts spinning. I'll use my handheld tachometer to verify the speed, and yep, it's exactly what it should be. My motor's free spinning with no load, so the default PID parameters work just fine. But if you need to tweak the PID tuning, the manual walks you through how to do that in just a few sentences. Just remember to readjust the current limiting potentiometer once you get PID working the way you want. Your analog drive manual will tell you how to do that. Now, if you just want to use the digital potentiometer as a simple replacement for the analog potentiometer and run the drive as an open loop controller with no feedback, well, just go back to parameter 22 and set it to a 32 for open loop operation. And of course, change all these back to whatever you would normally set them to. Now keep in mind, since we're no longer using the feedback, you need to make sure the digital potentiometer is set up for rate mode only. It won't know what to do with the other modes because there's no feedback signal for it to use, right? By the way, even though the drive isn't using the feedback to control the motor in open loop mode, you can still connect it to a sensor and display the results to monitor anything you want. It won't have any impact on the drive because it's in open loop mode. Now, one side note. If you know you'll never use the feedback and you only want to use this as a simple replacement for an analog potentiometer, then take a look at this guy's cousin. It doesn't have the closed loop option, so it'll save you some money. This digital potentiometer has one more really great feature. You can add option modules to communicate with it and to give it analog input, analog output, and a digital input, just like the regular GSD8 digital drives. I'm planning to do some videos on those option cards, so be sure to click here to subscribe to our YouTube channel so you'll be notified when we create new automation videos. Click here to see the rest of the videos in this series, and click here to learn about Automation Direct's free technical support options.